class yesterday, so you might not recall everything we covered on Monday, but let's try to see if I can jog your memory. All right. Can anyone tell me what probability is? Chance of something happening, the likelihood of an outcome, right? So likelihood of an outcome. And what does mutually exclusive mean? Pam?
That means that if one event happens, the other one can't happen, and vice versa.
So can anyone give me an example of like mutually exclusive events? John?
Heads or tails on a coin flip?
Yeah, heads or tails. You're either going to get heads or you're going to get tails. It's not going to land on its side, hopefully. So only one can happen. All right. And then union. Does anybody recall what would be filled in if I said that there was a union between events A and B? Jamie?
The middle part? The parts where they overlap.
Yeah, so that's when they're overlapping, but a union, like what do we think when we think of a union?
Marriage, holy matrimony.
Yeah, marriage, holy matrimony is one thing. What else?
Country.
Coming together. All right, any other? Joining? And so do we think of like a small bit when we think of a union or more encompassing? Big. All right, so,
Every part would be filled in.
yep, so every part would be filled in. All right, and so then what portion would be filled in an intersect? Just the overlap, because it's where they intersect. All right, so that's what we covered on Monday. And so today, we're actually going to cover a couple new topics called conditional probability and independence and dependence. So I'd like to ask you guys a little bit of a scenario. So let's say we take someone at random from the U.S. population. What do you think the likelihood that they're over 6 feet tall?
45%.
35%? That's the whole population. All right.
Like 5%?
Not even adults, right? So it could be like
Yeah, it could be like kids too.
Wow.
5, 10%.
Wow.
12? Wait,
12.
12?
No.
3%.
3%.
Yeah,
I think
Really?
there are a lot of
It seems like most guys are like 6 feet or taller.
Yeah.
So
All right.
that's about half the population. So we can't be like 10%. That's way too low.
And then all the children.
Baby.
Yeah, but
Yeah.
still.
That's tall.
So I've heard a lot of
Meaning men are
numbers,
not
but
6
let's
feet
go with like 20%, right? So 20%, you pick a random person out from the U.S. population, right? So now let's say we pick a random man out of the U.S. population. What's the likelihood they're over 6 feet tall?
Higher.
45.
No.
42.
No, I'd say
42.
over 50.
No. 41.
So I've heard 40, 41, man, I hope no one's short in this class. So 40, 41, but it's definitely going to be higher, right?
Yeah.
All right, so let's put 40%. And so don't feel bad about these numbers because 43% of all statistics are made up on the spot anyway, so. All right, so over 6 feet tall and a woman.
3%.
Are we choosing just out of women?
Just
Or
out of
the
women or
general
female.
population?
5%.
5%? So this one's the general population, this is just out of males, and this is just out of females. So I've heard of 5%. Ruthie, do you have any idea?
Maybe 2%.
Maybe 2 feet. I've actually met a couple girls over 6 feet tall.
Are they wearing high heels?
So 2%, but definitely lower. So let's go with 10%. We have a really tall population apparently. And then female. So what differs between these populations and the general U.S. population?
The population size is smaller.
The population size, yeah, it's a subset of the general population.
They're mutually exclusive.
They're mutually exclusive. They're either male or female. All right. And one other thing is, out of the general population, you choose if you're gonna select from male or female. So you take the general population, and then you select a subset of that population. And that's conditional probability. The probability of an event, given that you've already chosen an event. And in this case, our event would be male or female. So I'm going to pass out a handout while I write some definitions on the board. All right. Could you pen that? And so you guys remember our KWL we've done before, right?
Yes.
Okay. So you're going to fill out the first two parts and copy down the definitions, and I'll give you about 3 minutes to do this. All right, and so I'll give you the mathematical definitions and the equations to use those. But first, does anybody want to share anything they've included on their KWL? Has anybody written anything on their KWL?
Yeah.
No.
All right, Pam?
I don't know the term that probability is between 0 and 1.
Probability, yep, you definitely know that about probability, so conditional probability is exactly the same. Alex?
One thing that I want to know is the probability of multiple events happening in a row.
Oh.
Like, you know, like lotto tickets, kind of like you have to get all
All
of
the numbers.
numbers.
physically
So like,
correct.
what's the probability of all this?
All right. Anybody else? John?
I started writing what I know about independence before you wrote the definition up there. I said it means freedom, so that might be talking about probability. We might be thinking that one event isn't connected to another. And I guess that kind of works for me.
So this is the more formal definition, but I really like yours. It's essentially freedom. One event is done freely and doesn't affect any other events. So now let's start doing the math, which is, oh no, fire drill.